So scientific libraries are an add-on to the Python language in a very important way, in that they provide really efficient calculations of specific types that are very common in most data science and machine learning applications. So NumPy and SciPy are this collection of functions that have an enormous amount of active research behind them. How do we efficiently calculate really large-scale operations of specific types? So one of the first important things, and we'll talk about it in this chapter, are efficient matrix operations. So when you have these really large dimensional arrays and you have to perform addition and subtraction and taking the inverse of these really big objects, it's important that you do that efficiently based on the characteristics of those matrices. We don't need to know how it's done, but just to know that if you implement it yourself in base Python, it will be much slower than if you use NumPy. In addition, there's other really important operations that we get out of these packages. Things like random number generation, and it's a substantial scale. We'll talk some more about that, and you'll have some assignments on random number generators here in a bit. Also, they handle homogeneous data. So NumPy is for numbers. Hopefully that makes sense. So the arrays are all of one data type. You'll see heterogeneous data in the next chapter when we talk about pandas and when you have objects that have different types of data. But here NumPy is assuming that you have matrices typically of numbers, and that will usually be the case in many of the algorithms that we implement. Even if you have non-numeric data, you typically convert it and normalize it before you start doing operations. And lastly is that these are easy to implement. We'll do a couple of examples here in the next few sections, but you can write with just a few lines of code NumPy calculations that typically would take by hand an extremely long time to do.